Hi boys and girls, today we're going to talk about erosion and deposition. So what is erosion? It's the movement of sediment by wind, ice, water, or gravity. Erosion is movement. What is deposition? It's the process by which sediment drops out of the wind, water, ice, or gravity that carried it. Deposition is dropping. There's Isaac Newton, and he talked about gravity and thought about it, and we learned about him when we were learning about the solar system and the universe. Sediment falls because of gravity. So there's erosion by gravity, and in order to understand that, you have to understand the angle of repose, which is the steepest angle or the steepest slope at which a material will not slide down. Think of yourself at the top of a slide. Think of yourself before you slide down the slide and you're kind of stuck. Well, that would be the angle of repose. So you can see here that you have sand and loose gravel and cement stacked up. The sand can stack up at an angle of 42 degrees, but the loose gravel can only stack up to an angle of 33 degrees, and that's based on the particle size. The larger the particle, the lower the stack, the natural stack. Okay, so you can see on the left here, we have some fill dirt and it can stack up nice and high. You can see a very nice, even, pointy kind of pyramidal shape there. And on the right-hand side, you have a lump, and those are chocolate particles. And the chocolate is larger particled, so it can't stack as high as nicely in that slope. So when things are deposited, it's called mass movement. And that's when the gravity moves the material down a slope. And there's lots of different types of mass movement. You have to be able to keep these straight in your mind. Landslide is when the rock and soil, the land, move quickly. They quickly move. It's a landslide. Slump, think of yourself slumping in your chair. All of a sudden, you just fall in a big mass. Exhale and relax, and your whole body will slump down. That's called slump in mass movement with soil as well. Creep, when you're creeping up behind somebody slowly, ever so slowly. And then mud flow is obviously with mud flowing down the hill, and an avalanche is snow going down the hill. So what type of mass movement is in each picture? Number one on the top left there is a, yes, landslide. Number two on the right, you see all the water? That has to be a mud flow. On the bottom left, where that roadbed has suddenly slumped, and that car is at the bottom of that roadbed at the bottom, way down there. And number four, you can see creep because you can see the trunks of the trees have bent tremendously. The tops of the trees are going for the sun, so they're going to go straight up. The bottom of the tree trunk there is falling over, and it's falling over so slowly that the whole tree doesn't fall over. It can adjust, but when you see that, you know that the hillside is slowly creeping. All right, so ice can do things too because glaciers carry the sediment. Glaciers are so heavy that they melt from the bottom because of their weight, and it's a density thing, changing. And they carve because when they melt, they reduce the amount of friction, and by reducing the amount of friction, they slide around. When they slide around, they slide on the rocks, and they take the rocks with them. Remember we talked about glacial scarring with Alfred Wegener, and this is because the glaciers can scar or carve the rock. This picture is a picture of Glacier National Park over time, and the glacier has carved this mountain range, and it will continue to carve the mountain range over time. And you can see we're at 2030, 2040, 2050. It's getting larger and larger and larger because of the glacier. So there's ice erosion with the glaciers. And there are two types of glaciers. There's continental glaciers, which are They cover a continent. They're flat. They're not in mountains per se. They're over flat areas. That's why they're called continental glaciers, and they smooth the land, flatten it out. This is why Wisconsin is so flat and smooth, because it was once covered with one of these continental glaciers. Continental glaciers cut out kettle lakes. Alpine glaciers are in the mountains, and they make the land look really rugged, and they make horns like the Matterhorn, which are sharp pyramid-shaped peaks, very dramatic. Mount Everest, I think, is a horn as well. They also make U-shaped valleys. It's because of the shape of the valley. It looks just like a U. Okay, here's an annotated picture of a mountain range. You can see some horns up there. They're very dramatic peaks. You can see some U-shaped valleys, and you can see the glacier moving in that river form there, a couple of them. Here's an example of a kettle lake. See how round it is, and it's flat. It's doesn't have to be very large either. Ice deposits things like tills, which is unsorted deposited rock material. And they deposit this till in a moraine, which is along the edge of a glacier. It's just rocky junk. Or you can also get stratified drift. Strata meaning layers. You learned that earlier in our rocks unit. Strata, well, also in our atmosphere unit with the stratosphere, with the layers of the atmosphere. So anyway, you have stratified drift, which are layers of rock deposited based on their size. The larger ones would be on the bottom, and the finer, smaller ones would be on the top. And they get arranged in this thing called an outwash plain, which is a large area of this drift. You can see strata right there. Didn't remember. There you go. All right, so here's a giant glacier. You can see that the glacier is moving toward you in this picture. And if you look on the edges, you can see some till. You can see just the junk, and you can also see how the glacier has carved different ridges in these mountains. Which type of glacier or landform is represented in each picture? Number 1, with a flat glacier, it's continental glacier. Number 2, top right, with a peak of a mountain, it's an alpine glacier. The continental glacier made the Kettle Lake there on number 3. And can you see the shape of the valley in picture number 4? It definitely looks like a U. It's a U-shaped valley there, made by the alpine glacier. So here are some more glacier deposit-y type forms. We have the outwash plain. It's flat, just a bunch of till. And we have the moraine. You can see this rocky, just junky spot there. It's the edge of the glacier is called the moraine there. So we have wind. Wind does a lot. It's not as powerful as water, but it is still pretty powerful. You can see it pumping there and irrigating those vegetables. So wind will blow sediment, and so wind has a lot of deposition. When it stops blowing, it will deposit. So sand dunes. When you think of sand dunes, they're mounds of wind-deposited sand, and they move in the direction that the wind is blowing. So for example, if you have a south wind, which we learned about in meteorology, the south wind blows from the south to the north, so the sand dune will be creeping to the north over time. Loess, one of my favorite words, loess. It's just fun to say. Anyway, there are thick deposits of fine-grained, wind-blown sediment. This is loess. It's very fertile, and the Dakotas have a lot of loess in them, and that's why they're so fertile. So here's some water. Water has a lot more power than wind, but water is definitely a good eroder and depositor. So what kind of water? Rivers, oceans, rain, etc. They wash up the sediment. Water washes. Water will move that. So here's some erosion. We're going to move things away. We have Sea cliffs, where rock wears away. Sea caves, where you get a hole in the rock. You know what a cave is. Sea arches, just think about an arch cut into the rock by the sea. And a sea stack, which is like a sea arch that has been weathered all the way through, and it's an offshore column of rock that once was connected to the mainland but is no longer. Here's another test. Let's see, we're looking out from a sea cave. We're going to go down this time, and we're seeing a bunch of sea stacks. At least all these words make sense, right? It's a cave, it's a stack. Number 3, there's that arch. And number 4, that would be a cliff. There you go. So water deposits in deltas, which is when this river slows down and the current drops the sediment in a fan-shaped pattern at the end of the river. We have deltas. Think of the great big Mississippi Delta at the end of Louisiana. Think of the Egyptian Delta at the end of the Nile into the Mediterranean. Think of the Sacramento Delta. The gold rush people had to deal with that. Or think of Savannah. The water coming out of the river in Savannah would make a delta as well. And they have to dredge and keep that harbor clear so that the boats can go into it. And it keeps getting more and more filled up because the river brings more and more sediments down to the end of it. That's a delta. Okay, so sandbars, they're offshore deposits of sand, gravel, or shell material, and they're off the coasts of islands, off the coasts of continents. They're in the middle of rivers. It's where any current could just slow down for a little bit and drop some sand, gravel, shells, and you'll see these at the Chattahoochee. Where we live, there's a lot of sandbars in the middle of the Chattahoochee there. You have alluvial fans when wind water carries sediment through a narrow opening between the hills, and it drops out and forms a fan shape. Alluvium, which means basically sediments and dirt, and it drops into a fan shape from wind or water. Beaches, you know what a beach is, so that's pretty easy. And a beach can be on a river, on a lake, or on the ocean. Here's our mini test. Number 1 is a delta. You can see the sediment being dropped into the water. Number 2, sandbar. It's a little bit of a sandy raised area. It's not big enough to be an island by any means. It's just a little area, and usually they're long and thin, so that's like a bar shape. Number 3 is obviously a beach, and number 4 leaves the last one to be an alluvial fan, and you can see the fan shape, and you can see at the bottom, at the top of that little A area, there is the opening where the alluvium came out and went that way. Thanks a lot, boys and girls.